our test the last time?
I could give it back when you said any time,
Okay.
it turns out. Okay, so we were talking about scientific notation, significant figures, and with significant figures, sometimes we have to write them in scientific notation. I think most of you probably learned this back in math about scientific notation, but we use it to write either very large numbers or very small numbers. Now, the form that scientific notation takes, you see where on the second line there where it has capital M times 10 to the n. The m is going to be the number. It has to be greater than 0 but less than 10. So in other words, like from 1 to 9. It has to be, we put the decimal after the number that's between 1 and 10, and then you can have some digits after that. And then the n is going to be a whole number, and it's the power. It could be negative, it could be positive, depending on which way the zeros are placed, okay? So here we have a number like 0.00012 millimeters, and we want to change it into scientific notation. So I move the decimal point so that I have only one number to the left of the decimal, and it can't be 0. So we are moving it to right after the 1. And then I write down all the significant digits. Well, in that number, the only significant digits are 1 and 2, so 12. So I'm going to change it to 1.2, so that's where the 1.2 comes from. I moved it over so that there's only one number in front of the decimal point. And then I write down all the significant digits, so it's 1.2. And then since I moved it to the right, it becomes a negative exponent. If I had moved it to the left, it would become a positive exponent. And I moved it over 4 places, it says. So that's why it's -4. Okay? Just a reminder of how you do scientific notation. I think most of you know how to do that, but just to make sure, in case you don't. Okay? So you move the decimal point 4 places to the right, and then you multiply it by a -4. So here's how I like to remember it when I was learning this and trying to remember it is, when I take the first number that I have right here, that's a very small number, and I made it bigger. I went from 0.0012 all the way up to 1.2. I made the number bigger, right? So I have to do something that makes the number smaller. The times 10 to the -4 is smaller. So if I make the number bigger by moving the decimal, then I have to do the opposite with the times 10 part. If I made the number bigger, I'm going to have a negative exponent. If I made the number smaller, I'm going to have a positive exponent. So you determine the m by moving the decimal point to in the original number to the left or right, so that you have only one non-zero digit to the left. And then you determine n by just how many places I counted it. So I think all of you know how to do this. It's just a little review of that. So if you moved it to the left, the n is going to be positive. If I moved it to the right, the n is going to be negative. Now, when it comes to doing math with scientific notation, that can sometimes be an issue. Not with multiplying and dividing, it can be an issue when you're adding and subtracting. To get to round to the right column. So when you're performing addition and subtraction, these operations can be performed only if the values have the same exponent. In other words, you have to change them so they both have the same n, the same power of 10. if one of them's -3 and the other one's -5, I have to either make both of them -5 or both -3, otherwise I won't be able to do it correctly. That's what that's saying. Okay, so here's an example. I'm adding these together, and I have 4.2 times 10 to the fourth and 7.9 times 10 to the third. To round those to the right number of significant digits, which remember addition goes by column, I have to make sure that they have the same power of 10, so the columns will be lined up. If I don't, the columns aren't lined up at all. So I'm going to have to either change both of them times 10 to the fourth, or both of them to 10 to the third. Or I could pick to change both of them to something entirely different, but they just both have to be the same. So notice over here, when I moved both of these over to 10 to the fourth, notice now that the columns look different. At first you'd had 4.2 and 7.9, well, they have the same number of significant digits, but when you're adding and subtracting, we're not going by how many digits, we're going by column. And notice that when I add the 4.2 and the 0.79, I get 4.99, but I need to round it to the one place past the decimal, because the 4.2, the 2 is in the tenths place. The 9 in 0.79 is in the hundreds place. Which column's farthest left? The tenths. So I round off to this place right here, which will make it 5.0 times 10 to the fourth. Now, if I had changed it times 10 to the third, I still do the same thing. This is in the ones column, that's in the tenths column. Which column is farthest left? The ones column is. So I have to round to the ones column, which will make it which would make it 50 actually, or 4.99, which would make this 50 times 10 to the third. Well, 50 times 10 to the third is the right answer, but it doesn't, it's not kind of like our standard way of writing it. We always want to have only one number in front of the decimal. That has two numbers in front of it. 50 times 10 to the third has two numbers in front of the decimal. So I have to move it to 5.0 times 10 to the fourth. So this is when it comes to scientific notation, it's really only adding and subtracting is the rule that you have to take a little more caution with. But when it's multiplication, you just do it like normal. On your calculator, you'll just put in 5.3 times 10 to the 6th. Now, here is one thing, that depending on what calculator you have. If you have an older calculator, then entering a number like 5.23 times 10 to the 6th. What you're going to want to do on your calculator, you're going to want to enter, just type in 5.23, and then in place of times 10, because this is where you get into issues with this, is to use the button that you have on your calculator. That yours will either say E or EE. It's not if it's not an actual button, it'll be right above the button. Like on mine, it's mine is right above the comma on mine. I don't know where it is on yours. Your calculator is very similar to mine, right? So you see the little EE right above your comma. On yours, your E or EE is, where is it at on yours? Well, yours is a Casio. You might have to look at how to do that on yours. Yeah, if you have a Casio, it handles a little bit different. So I would encourage you to read your manual, go to the part where it says scientific notation and see how they enter it. If you have, I just know how to do TI. I'm not familiar with Casio. They just do it a different way. It doesn't mean that it's bad, it's just a different way. Which brand do you have there, Katie?
Texas Instruments.
No, TI, what, 30X or something like that? Okay, did you find that button on your calculator? Okay, so put that in, and it'll be an E. On some calculators, it's a E that's as big as the numbers, and some it's a little tiny E. I don't know what it looks like on yours. And then type 6. That's the way you enter that number on your calculator. Then you'll do times. And then like you put in 7.1 E, and then be careful that you don't push, it's not minus, like subtract 2, it's a negative 2. So make sure you put the negative symbol, not the subtract. If you put the subtract in there, I think it might even give you an error message or a wrong answer anyway. Yes?
That's for scientific notation.
Yeah, when you're entering scientific notation on your calculator, that's the way I would want you to do that. Could you put in times 10 to that? In other words, actually type in times 10 to the caret 6. Yes, you can. But you have to make sure that you put that in parentheses. Because your calculator thinks if you take it with a times this, it thinks that you're multiplying this number by this number. Then if you're dividing, let's say by something, then the order of operation comes into effect, and you can end up with, like, I'm trying to multiply all of this by all of this, but if I write it like this, it's only multiplying this by that, not the first one necessarily. So that's the reason why I would encourage you to use the E. That's why they put it on your calculator. When you use the E, it thinks it's all one number, just one number. It's not two pieces. If you write it like this, your calculator thinks it's two pieces, which can be a problem sometimes. Not always, but it can be. So let's go on. So they're just showing you how they did that, but on your calculator you should have 37.133 times, or e to the 4.
Not quite.
Well, yours 3.7133 e to the 5th, right?
I have 371330, no decimals at all.
Yeah, so that's what I.
No e at all?
No.
Nope. Okay, so let's see what we.
But if you put it in scientific notation, it's right.
Oh, okay. Yours is not in scientific notation. You just took it out of scientific notation. So you just take your answer, and if you put it into scientific notation, would it be their answer? Yep.
You used the negative sign though.
A negative, that's that one. That's what that down on the bottom. Okay? What Ben's asking is, where on your calculator is the negative, not the subtract? Do you have a key? Look for a key that on the TIs that looks like this. It's usually down to the bottom right is where it's at. That's where mine's located. Mine's located right down here next to the enter key. But that's the negative, not the subtract thing. The one over here is my subtract. Yeah, now on your calculator, Katie, can you, let's see, do you have a button on, or a key on there that goes with mode? You have a mode up at the top. Oh, here, I guess yours is, you can set it to be scientific notation, I think. Or scientific. Oh, no, I have to do second first, don't I? clear that, do second this. So now you have the FLO stands for floating point math. It just means that the decimal point moves around when it's necessary, but not in scientific notation. But if I select this, then I think my answer would now do the same problem and see if it won't give it in scientific notation. And it does. Yeah, it'll change your answer from, so on your calculator, yeah, you have, do you see where it says SCI/ENG? Press second and hit that button, and then it'll give you the option to go from, see, what was it, floating point, FLO for floating point math is what it means. Means don't put it in scientific notation, just keep moving the decimal point around. And then you have one that's called SCI, that's scientific notation, and I think you have one that's what, ENG for engineering. I'm not sure what that means. Yes.
So at the beginning, before you start multiplying anything, you just put in, you press the second number, then SCI/ENG.
Oh, yeah, if you want your answers to come out in scientific notation, just do this before you start doing your math, yeah. So round it off to how many significant digits should my answer have? Okay, so when I'm looking at deciding which one, I only have to look at the stuff in front of the times 10. Remember, all of those are significant. So 5.23 has how many? 3. 7.1 has how many? 2. So my answer should have how many? 2. That's why it's 3.7. Right, good? Division, much the same thing. You just obviously push divide on your calculator. Now, yours probably won't show it that way, would be my guess. If you have yours turned to scientific notation on, it'll probably show that. 6.716049. I mean, it's lots of digits, but it's way more than I need. So how many digits should this one have? Well, I go by the one that has the fewest, and I'm looking at the part that's in front of the 10. It should be 2, right? Should be 2. 6.7 times 10 to the second. If you have it on those calculators, have it back in the flow mode, the floating point math, it will read it'll read 671 something, with lots of digits after that. So the only time it has to be in scientific notation is if they're specifically asking for it, which usually they don't, or that is the only way I can display the proper number of significant digits because I have zeros in my answer, or zeros at the end of my answer. Okay, that's the only two reasons why you'd want to put it in scientific notation. They were specifically asking for it, or I have zeros that I want to be included as significant digits. Okay, so when it comes to solving problems, we're going to first step in solving a quantitative word problem is to read the problem carefully, probably at least twice. It's amazing how many times when I'm helping like my AP Physics students, we go back and reread the problem, and the problem they thought they were having, they no longer have because they realized they were solving a problem that wasn't even being asked for. They were making up their own problem. So make sure you read it. Then the second step is develop a plan to solve it. Quite often this year is look at where you want to end up at and then figure backwards. Have you ever noticed this, that on a lot of mazes, if you have to solve a maze, what's the easiest way to solve a maze? Start at the end. and go backwards. It seems like it's always a lot easier to solve it from the back end than start from the front end. Front end, it's designed to have so many dead ends, but you don't run into the dead ends when you go from the back end, you know? So then you obviously go ahead and solve what you need. So write down what you're given. That's always the good key, like we learned back in physical science. You always list what you're given, and then pick your formula or your plan of how you're going to solve it from that. And then obviously you need to check your answer to see if it's reasonable. Am I coming up with the right unit? That's the best thing to do is, am I getting the right unit for this answer? If I come up with the wrong unit because my units don't cancel out, you're pretty certain that the way you solved it was incorrect. You don't even have to, go through it again. Wrong answer, wrong unit, probably wrong work. So check to see if the units are correct. And then estimate to see, does that answer even sound reasonable? One of my favorite examples to give was my AP Physics students. They were supposed to calculate, or they're supposed to determine the height of one of the students from their shadow alone. All we knew is that all they could measure is the person's shadow. They couldn't actually measure the person. And I told them that the gym, how high the gym was. The roof of the gym. I told them how high that was. They knew that, and they could measure the shadows of the gym and the person, but from that they were supposed to figure out how high or how tall the person was. And they came up with 20 meters. Does that sound reasonable? Well, a meter is about like 3 feet. So this guy is 60 feet tall. So probably made an error in what? Sounds like. Maybe a decimal point went off somewhere. They lost their decimal point. 6.0 feet sounds reasonable, right? But not 60 feet. Even Goliath wasn't even that tall. And then check your order of magnitude. One of the quick ways of checking an answer is don't use the actual numbers. Round off to numbers that you can easily do in your head, like to the nearest 10 or to the nearest 100 or something like that. And then you can come up with an answer that, and does your answer kind of fit in that range? And then at the very end, you just want to express your answer in the proper number of significant figures. Okay, so here is some problems that we can do yet. Calculate the volume of a sample of aluminum that has a mass of 3.057 kilograms and a density of aluminum is 2.70 grams per cubic centimeter. Now, as you look at the problem, is there something you know already is going to give us some trouble? Two different units. I have kilograms and grams. So we've already identified a potential problem right there. Okay, so the first thing I'll do is I analyze it. Analyzing it means just listing what's given. Okay, so remember, to show your work, you have to list what's given. So M is equal to 3.057 kilograms. D is 2.7 grams per cubic centimeter. And my unknown is, what is the volume of aluminum? Now it looks like my volume units should turn out to be what? From the information given, what's the volume units going to be?
Centimeters cubed.
Yeah, centimeters cubed is going to be my volume. Okay, now, so density is grams per cubic centimeter, the mass is in kilograms, so I'm going to have to change the kilograms into grams. So that's one of the things I'm going to have to do. So I'm going to rearrange the density equation to that. We have it up here on our board with our magic triangle. M over V, and then the capital D is also on the bottom. I'm trying to find out volume. So if I cover up volume in this equation, I have mass divided by density. So I rearranged it. It should be volume is equal to mass divided by density. So I put my numbers in the appropriate spot. I need to change the kilograms into grams by multiplying by 1,000 first. And then my calculator answer will say that. Now what's the next step? Write it in proper scientific notation. Should have how many digits? How many significant digits does my answer have? 3.057 has how many significant digits? 4. Okay. 2.70 has how many? 3. So my answer should have 3. So round that bottom number off to 3, and what would I write? Okay? So I'm going to look at go 1, 1, 3, that's 3, but there's another digit after it, so I'm going to use that to decide if I need a round. Do I need a round? No, but then if I take the 2 away, I need to put a placeholder in there, right? Which is not a significant digit, it's just a placeholder, but it's 0 there. So my answer rounded off to 3 significant digits should be 113. Or if you write it in scientific notation, that's what it would be. So 113 cubic centimeters, or 1.13 times 10 to the third, both answers are correct. Just 2 different ways of writing the same answer. So to check your work, the volume is that. The unit for volume is cubic centimeters, is correct. That's the right kind of unit I would expect for a volume. And order of magnitude, what we did there is it was 2.7. Well, let's round it off to a whole number, like 3. The other one was 2. Was the density was around 2, so 3 divided by 2 is about 0.6. 3 divided by 2 is like 1.5 times 1,000. So, just checking if it's reasonable. You don't have to use the actual number. If you have a calculator, it's really, maybe some of this isn't, but if you're just checking in your head. Okay, so what we have left to talk about is the concepts of direct proportion and inverse proportion, and how can I recognize which one it is. Okay, so variables that are directly proportional increase or decrease by the same factor. If I double one, I double the other. If I cut one in half, I cut the other one in half. So that's what we mean by a direct proportion. So 2 quantities are directly proportional to each other if dividing one by the other will always give you a constant value. Yes?
What does proportional mean again?
Say what?
What does proportional mean again?
Thank you. Like in math, if 2 things are proportional, if they change in the same way, like doubling one doubles the other, cutting one in half cuts the other in half, then they are proportional. Directly proportional, because I'm doing the same thing to both. So, let's say we could say that y is proportional to x, and the symbol for proportional to is kind of like the infinity symbol, but at the end chopped off, or kind of like the fish symbol, I don't know, whatever you want to look at it. That's a symbol for being proportional to. So we're saying y is proportional to x if y divided by x is always a constant. If y divided by x is a constant, then it will be directly proportional. Also, the other thing is if y divided by x, rise divided by run, is always a constant, then it's got to be a straight line, right? If rise over run is always the same, then it's gotta be a straight line. So up here I have it written, if A divided by B is a constant, it's a direct proportion. If you look at the graph down on the bottom, if you can see it, because of our lighting issue, is a straight line, it is also a direct proportion. So we have ways of determining if two factors are directly proportional by looking at, is one divided by the other always giving me the same answer or very nearly the same answer? It's a direct proportion. Or if I graph one against the other, does it make a straight line? So straight line and one divided by the other is a constant are the two factors that determine or help you know that two factors are directly proportional to each other. So here's the graph that I'm saying, and you can use that to, so like if you did this bottom chart, this is maybe, let's say, the result of your your lab, and you take one divided by the other, notice that it's almost exactly the same, not exactly the same, but close. Remember, these are human measurements, so it's going to be off a little bit. But when I graph them out, it comes out to a pretty nice straight line. Then you know that these two factors are directly proportional. If I double one, I double the other. Cut one in half, I cut the other one in half as well. Now, quantities are inversely proportional if one decreases while the other one increases. It's kind of like they're going in opposite direction. If I double one, I'm cutting the other one maybe in half, for instance. Or if I cut one in half, I make the other one twice as much. You know, they're going in opposite directions. So two quantities are inversely proportional if their product is a constant. If one multiplied by the other always gives me the same answer, it's inversely proportional. So back to the question about what's proportional mean. I'm doing just the opposite things to each other if they're inversely proportional. In math, what does inverse mean? Like, or tell me, what's the inverse of 3? 1/3, right? So if I'm multiplying one side by 3, the other one I'm multiplying by 1/3. I'm doing the opposite with the other one. So that's inversely proportional. Notice we're writing up here as 1/x, indicating that they're inversely proportional. So y is proportional to 1 divided by x. Well, 1 divided by x is the inverse of x, so I just tack that on, put that in front of proportional and say inversely proportional. Or y is proportional to the inverse of x, right? That would be another way of saying that. Because 1/x is the inverse of x, is proportional to the inverse of x. Now just put the inverse in front of proportional, we can call it inversely proportional. So the graph of this one is not a straight line, so you won't confuse these two. This one is in math is a hyperbola. How many of you have studied that in math already? A hyperbola. None of you? Okay, so it looks like this. So if it's going to be curved downward like this, that is a hyperbola. Now, to be a hyperbola from math, if you take the left side, see how it's curving up? If that curves, and if you just kept going farther and farther, it's getting closer and closer to some value, but never quite reaching it, but it's getting more and more vertical. And on the bottom side over here, the longer and longer I go, the more and more horizontal it's getting. So that shape is called a hyperbola. But if you graph something out this year and it's curved like this, then you know it's an inverse proportional. If it graphs out at a straight line, you know it's directly proportional. And if you graph it out and there's no pattern at all, then they're not related to each other.